My name is Santawat Thanyadit from Hong Kong University of Science and Technology. Today I would like to present our work on desktop virtual realities using mirror metaphor for natural user interface. So I would like to start with a little bit of background why I work on desktop virtual realities. Our lab is interested in using virtual reality to improve office and classroom environment. However, the head-mount display is limit the user view, and it does not scale really well to a larger crowd due to its high cost and it requires special equipment. Another important issue in head-mount display type VR is that it is inconvenient for the user to switch between different tasks, for example, VR tasks and desktop tasks, which is very common in this type of environment. So we look into another type of VR, which is desktop virtual realities, also known as fish tank virtual realities. This type of hardware is proposed by Colin Ware and colleagues in 1993. It consists of two main components, the 3D display and the head tracking. The head tracking information is used to generate a 3D screen according to the user perspective. So the user could experience the motion parallax and the 3D effect at the same time. There has been recent work on fish tank virtual realities, but most of the work are more or less the same concept. Of course, desktop virtual reality have more suitable property for the classroom and office environment. It has relatively lower cost, less setup time, and it's actually integrated well into the workstation because it already have a desktop in front of you. And the user can switch between applications without removing the 3D glasses. But its downside is that it has lower level of immersion and smaller screen size and smaller interactive space. So we try to, since the user cannot reach to the screen, the past interaction in the desktop VR is limited to the virtual pointings or extended virtual hand, such as Coco techniques by Popirev et al. And colleague. But in this case, the user feels like interact with the objects using remote controller, which is not very natural. So in our system, we try to create a natural user interface in front of the desktop VR. We use Kinect sensor to track the user head position and leaf motion sensor to track the user hand. A 3D display is used for the user to view the scene in stereoscopic 3D. So in our system, the system generates the scene based on the user head position. The Kinect and leaf coordinate are combined into a single coordinate system. So the user physical hand and the virtual hand is aligned correctly from the user perspective. However, in this configuration, we have an issue. Since the virtual hand is aligned with the user physical hand, the user could not interact with the objects behind the screen because the user could not actually reach to the monitor. So to utilize this virtual space, we propose a mirror as an interactive metaphor. But why do we choose the mirror? The mirror is used in our daily life. We interact with the objects through the mirror, from simple tasks such as combing our hair to more complicated tasks such as doing the makeup. Visual mirror is used in commercial and research alike. For instance, a virtual try-on application allows the user to preview the clothes on customer body through a virtual mirror. For example, in the research, Bismarck and colleagues use the virtual mirror to provide extra information in the surgeon simulator. But most of the previous work on the mirror is use the mirror to provide extra information for the user. But in our case, we try to use the mirror as a 3D interactive metaphor instead. So let's look at the video on how the mirror metaphor works. So in the mirror metaphor, we treat the 3D screen as a barrier between the frontal world and the mirror world. If the user put the hand close to the screen, the virtual hand is transferred into the mirror world. The virtual hand is displayed like the reflection of your real hand And this way you can interact with the objects behind the screen. If the object is grabbed when you put your hand close to the screen, the object is transferred with the hand. Since the system tracks the hand separately, the user can generate experience that one hand can interact with the objects in front and one hand interact with the objects behind the screen. So we perform a within subject user study to see how the mirror compare with the classic go-go techniques, which is the technique common in desktop VR. The reason we choose go-go technique is that because it has many similarity with the mirror metaphor. We recruit 18 participants from our colleague in our use study, 3 of which are female. The age of the participant is between 21 and 49 years old. 30 of them were optical class, 9 of them have prior experience in the virtual realities. So the task is we ask the participant to align the cube in their hand to the target cube as accurate as possible. The participant have to alternately align the cube in the front world and the mirror world. For each technique, the participant had to go through the training section and recording section. Each participant have to align 5 cubes per section in total. So each participant have to align total of 20 cubes. We record completion time, position, and rotation accuracy. To save some time, we summarize the key findings. So for further detail, please refer to our papers. From the qualitative result, the mirror metaphor in the mirror metaphor, participants could actually control the object's position better than the go-to technique. We will show on the graph on the left, but it's a problem when dealing with the orientation in the mirror metaphor. We will show on the right. So another observation result is that there are less chance of occlusion in the mirror metaphor during the object interaction that is far away from the user. Because when user try to interact with the object that is far away, the hand is actually far away from the screen. Another advantage of the mirror metaphor is that it uses the same layer of control with the user's physical hand, so it is more friendly to the physical-based manipulation such as spring model. From the observation, there are some downside with the mirror metaphor as well. It requires some user adjustment from the user, especially when the hand is actually just transferred, so the user requires some time to adjust to it. It also adds additional transfer time to the system. To give you an idea of the use case of the mirror metaphor, we present a possible application scenario. In this scenario, the user is working on organizing file. The user can accurately pick the file from the file cabinet located in the mirror world, and transfer into the dedicated workspace in the frontal world. The user could use natural user interaction to interact with the virtual objects in front of the screen. When the user finishes, they can put the file back in the mirror world for the storage space. So this example application takes advantage of the separate space and position accuracy in the mirror metaphor provided. In the end, I want to discuss some possible future research. In our lab, we are working on cooperative learning tasks between 2 users. It is our vision that the instructor and the student can have their own private space. But when the student requires some guidance, the instructor can transfer the hand using mirror metaphor to help the student in the student space. Another possible area of research is using the point cloud, so the user can feel like they look at the mirror itself, look at the real mirror. From our informal questionnaire, the user feels more natural interacting with the virtual objects behind the screen when the point cloud is enabled, even though the point cloud can actually penetrate the virtual objects in this case. Okay, thank you very much for listening. I love to answer your question now.
Okay, we have some time for questions. Hi, Miguel Naventa from the University of St. Andrews. I think it's very elegant work, so thank you very much. I'm wondering a little bit about this distinction between egocentric and exocentric perception of 3D, because we know from the psychologists that these are different, and I wonder whether what you're doing actually essentially forces the user to switch from one to the other, and I'm not expecting really a precise answer about this, but have you thought a little bit about this, or what is your personal experience using it? Do you think that the brain now has to switch to kind of like a different mode every time I cross the screen boundary? And yeah, that's it.
Okay, actually we thought about it a lot because we want to try to this mirror metaphor to use in the cooperative learning environment. So we performed some primary experiment on this, and the teacher, we have like a setup of the teacher and student. So in that case, we've used the mirror metaphor. The teacher, when the teacher transfers the hand in, the student, the hand will look as if the teacher hand is actually over the student. So it's more egocentric view, and that's actually feel more natural for the user, for the student, instead of hand protruding out of the screen. But from the teacher viewpoint, is they have to require some adjustment for that, but it's more advantage for the student in this case.
I think just as a note, it would be also interesting to see what happens with personal space, because the psychologists have studied how like reachability of things actually change what we consider personal space or middle space, etc.
We rely based on the position of the screen itself, so we haven't studied on that. Thank you very much.
Thank you.
Okay. Do we have further question? Okay, I have only a quick question. What happens if the user wants to place the object direct in the baseline between zero parallax and negative?
Yes, we still have problem on that. It depends on our implementation. So as you can see, when the hand transfer is used, we set some time frame that the hand is transferred, and we can be set the range. So if currently we set the range like quite far from the screen, because not as far, but around like 5 centimeters from the screen, so that the leaf can actually track the hand correctly from in that position. But if we acquire a more accurate sensor, the screen position can be like this area can be minimized.
Okay, thank you.
Okay, thank you very much.
Let's thank our speaker again.